Solution to important problems on partial differentiation.
Hello future engineers and my dear students, welcome back to Mudassir Academy. I am Mudassir. In the previous video, we discussed the partial differentiation in a very simple way. We covered the introduction and solved some basic problems. I hope you understood what partial differentiation means and how to apply it easily. If you haven't watched the video yet, I strongly recommend you to check it out first. It's very important to understand that before coming here. So today in this video, I will be solving more problems on partial differentiation. These problems are extremely important from the VTU examination point of view, as they have been asked many times in the exams. As these problems are very important, so please don't skip any part of the video, watch till the end so that you don't miss any important steps. And if you are new to this channel, then please don't forget to subscribe so that you can follow along with the entire series on Engineering Mathematics 1. Check out this problem. If u is equal to log of s cube plus y cube plus z cube minus 3xyz, then prove that dou u by dou x plus dou u by dou y plus dou u by dou z is equal to 3 by x plus y plus z, and hence show that dou by dou x plus dou by dou y plus dou by dou z the whole square u is equal to minus 9 by x plus y plus z the whole square. This problem is very important and has been asked many times in the VT examination. Sometimes they ask here till around 4 to 5 marks, and sometimes they ask the entire question around 4 and 6 marks. So please don't skip any part of this solution. I try to solve in a very easy way so that the entire solution fits in the brain. Okay, so please watch till the end. Now, how to solve this? Let me write the question here. We have u is equal to log of x cube plus y cube plus z cube minus 3xyz. Now, there are some questions like this. Okay. These are standard questions. See the function here, log of x cube plus y cube z cube minus 3xyz. Such functions are called as symmetric functions. What? Symmetric function. Why symmetric? Because see in this question, if I am changing x to y, x becomes y, y becomes z, z becomes x, and again x, y, z, it keeps on cycling. Symmetric cycle. Okay. So now if you change say x to y, say y cube, y to z, say z cube, and say z becomes x cube minus 3, x becomes y, y becomes z becomes x. See, the question remains the same. This is called as what? Symmetric function. Are you getting it? In the function, the question did you by changing x to y, y to z, again z to x, if the question remains the same, the function here remains the same, we call it what function? Symmetric function. Okay, right here. So this is nothing but a symmetric function. So we call this symmetric function. A symmetric simply. Okay. Now, again what symmetric means? If I change x to y, y becomes z and z becomes. So x will become y, y will become z, again z becomes x. The symmetric cycle keeps on continuing. I hope you understood this now. Okay. So first see the question. In the question, we can change x to y, y to z, z to x, the question remains the same, it's symmetric. So, why? Because I show you what happens here. Okay. So, see what we need to show? Prove that dou u by dou x plus dou u by dou y plus dou u by dou z. We need to find all the three partial derivatives. Now, what happens? If you know it's symmetric, again I am repeating what symmetric means. X becomes y, y becomes z, z becomes x, cycle. If you simply find for one dou u by dou x, you need not find for dou u by dou y and dou u by dou z. Simply change x to y, y to z, and z to x. That's it. Very simple. That is the advantage of symmetric functions. So I identified symmetric function now. Now first we will find dou u by dou x. So we have dou u by dou x is equal to. So tell me how to differentiate this. Chain rule. Again I repeat, if you are weak in differentiation, again it's a very simple differentiation, but you are differentiating only with respect to x here. Okay. Log of x cube plus y cube plus z cube minus 3xyz. So log, first we differentiate what? Log. Differentiate log x is standard, log x is what? 1 by x. So right here, so 1 by x. What's the x? X cube plus y cube plus z cube minus 3xyz. 1 by. Again into chain rule, differentiation of this thing. First, log x is 1 by x, but it's not plain x. Instead of f, what is there? X cube plus y cube plus z cube minus 3xyz. Differentiate again that with respect to what? X. So, differential x cube is what? 3x square minus again 3yz as it is. See, I am differentiating only with respect to x. 3yz as it is, differentiation x is 1. Are you getting the partial differentiation here? We are partial differentiating only with respect to x. So, first whole log of x is 1 by x. So, we write 1 by whatever is there in place of x. Again, we differentiate x cube plus y cube plus z cube minus 3xyz with respect to x only. Partially differentiating. That is x cube, 3x cube is 3x squared, x cube, y and z is 0, and it's multiplied 3yz as it is, differentiation x is 1. Clear? Now, as I told you, there is no need to find dou u by again differentiate. Simply you can write, since it's symmetric function, dou u by dou y equals again, what I tell you, x becomes y, see 3y square minus y becomes z and z becomes x. That's it. That's it. And this bottom, the way as it is, it will become y cube plus z cube plus x cube minus 3y. It will be same as it is. It is x cube plus y cube plus z cube minus 3xy. See. Similarly, dou u by dou z will be again y becomes z, 3z square minus z becomes x, x becomes y upon x cube plus y cube plus z cube minus 3xyz. That's it. Okay. So, that's the advantage of symmetric function. So, first from the question, identify symmetric or not. Okay. If symmetric, then simply replace x by y by z, so on. Otherwise, we need to again differentiate that. Now, we need to show this. So, let us add them together. If we add them together, we get, that implies dou u by dou x plus dou u by dou y plus dou u by dou z equals. So, if you add them, I do directly here. The LCM is same. See, I am adding this all three. LCM remain the same. Okay. So, we write here now 3x square minus 3yz plus 3y square minus 3zx plus 3z square minus, what's that? It's 3xy. Okay. Upon, this will be same, x cube plus y cube plus z cube minus 3xy. You see. Now, I will write this as, see here 3 is common, I will group them all, x square plus y square plus z square. I will take minus c, I have taken 3 outside, this will be what, minus xy minus yz minus zx. Okay. Whole divided by, this will be x cube plus y cube as it is plus z cube minus 3xyz. Okay. So, this is what we have. Now, how to solve this? We have to bring this form 3 by x plus y plus z. So, how to move ahead? Recall in your 10th standard or whatever, 9th or 10th, whatever, the basics, you have learned a very important identity that time. If you recall it, I will write it here in this way. I hope you are able to recall it. We can write a cube plus b cube plus c cube minus 3abc is equal to minus 3abc is equal to a plus b plus c into a square plus b square into a square plus b square plus c square minus ab minus bc minus ca. So, by seeing this, I hope your memory is going back somewhere and you are able to recall this. What is that? A cube plus b cube plus c cube minus 3abc is equal to What's that? A plus B plus C into A square plus B square plus C square minus AB minus BC minus CA. So let's apply this here. So if you apply it here, what do I get? We can write this as 3 into say x square plus y square plus z square minus xy minus yz minus zx as it is whole divided by, now this whole thing I can write as x plus y plus z into, what is this? X square ABC becomes xyz, x square plus y square plus z square minus xy minus yz minus zx. That's it, beautiful. Now this whole thing cancels, this and this cancels. So that implies what remains? 3 by, what remains? 3 by x plus y plus z. Therefore that implies, I write it here the solution, we have dou u by dou x plus dou u by dou y plus dou u by dou z is equal to 3 by x plus y plus z. And this is the first part of the solution which we need here. Am I clear? So that's how it is done. So I am done with this first part here. Okay. So I done the first part. Now let's move on to the second part. What's the second part here? And hence show that dou by dou x plus dou by dou y plus dou by dou z the whole square into u is equal to minus 9 by x plus y plus z the whole square. So how are I going to do this now? So let's write it first what they are asking. So they are asking what they are asking. Dou by this thing, alright. Dou by dou x plus dou by dou y plus dou by dou z the whole square into u. See, I can write this as, see the square here. I will separate the square. X square can be written as x into x, right? So I write this as dou by dou x plus dou by dou y plus dou by dou z into again dou by dou x plus dou by dou y plus dou by dou z into u. Now that equals to, see, dou by dou x plus dou by dou y plus dou by dou z into, so what I will do is, I will take this u inside. What I do? I take this u inside this bracket. Okay, so this will be now dou u by dou x plus dou u by dou y plus dou u by dou z. That's it. Now, when I take it inside, you know the value of this. What's the value of this? Dou u by dou y plus dou u by dou x plus dou u by dou y plus dou u by dou z is equal to 3 by x plus y plus z. That's it. So this will be now again dou by dou x plus dou by dou y plus dou by dou z into 3 whole divided by x plus y plus z, which we have obtained from previous result. Now again open it. So we differentiate the 3 by x plus y plus z with respect to x with y and z. So we have this as dou by dou x of 3 by x plus y plus z plus dou by dou y of 3 by x plus y plus z plus dou by dou z of 3 by 3 whole divided by x plus y plus z. Okay. Now as you know, differentiation, see, we are partially differentiating here. Keep in mind, as I told you, a very important differentiation is differentiation of 1 by x is equal to minus 1 by x square. Please again remember it. If d by dx of 1 by x is equal to minus 1 by x square, d by dy of 1 by y is equal to minus 1 by y square, d by dz of 1 by z is equal to minus 1 by z square. So d by dx of minus like 1 by x, d by dx of 1 by x is equal to what? Minus 1 by x square. See here you are differentiating only with respect to x here. Why is it is constant? Keep in mind here partial differentiation. So we have here this as 3 as it is minus differentiation of 1 by x is minus 1 by x square. So minus 1 by x plus y plus z the whole square. Again plus. Is it again plus into again differentiation of 1 by x plus y plus z with respect to y is same thing minus 1 by x plus y plus z the whole square. So again minus 3 divided by x plus y plus z the whole square. Again the same thing repeats here. Dou by dou z of 1 by x plus y plus z. Differentiation of 1 by z is minus 1 by z square. So differentiation of 1 by x plus y plus z is minus 1 by x plus y plus z the whole square. So again minus 3 by x plus y plus z the whole square. That's it. Therefore, that implies add this all. So we have this as what asking. So that implies dou by dou x plus dou by dou y plus dou by dou z or dou by dou z the whole square into u equals what? Add all them minus 3 minus 3 minus 3 is what? Minus 6 minus 3 minus 9. That's what we need. So LCM is x plus y plus z the whole square. So we get this as minus 9 by x plus y plus z the whole square. That's the answer. Beautifully solved. That's it. Okay. I hope you understood the solution clearly. So first we find for this, that's dou by dou x plus dou by dou f dou by dou e by dou z is equal to 3 by x plus y z. Using this, we derive what we get next. As simple as that. So, but this needs practice, practice and practice to become more perfect. So, please watch this video how many times you want and practice it. This question can be surely asked for the examination. Right? The next problem here is if z into x plus y is equal to x squared plus y square, show that dou z by dou x minus dou z by dou y the whole square is equal to 4 into bracket 1 minus dou z by dou x minus dou z by dou y. Okay. So, let us solve this. See, you have a question here z into x plus y is equal to x square plus y square. They are asking dou z by dou x, dou z by dou y. Correct. So, I will write in form of z. So, z will be now x square plus y square by x plus 1. Now, this is again a symmetric function. It is what? Symmetric. Why? Because see here, if I change x to y, y to x, the question remains same. Right? So, if I change here x to y, it becomes y square plus y to x square upon y plus x. It remains the same. It's a symmetric function. So, x becomes y and y becomes x. That's it. It's a symmetric. Okay. So, as we have solved the previous problem. Now, so we will find first here for dou z by dou x. Right. So, let us find it now. Dou z by dou x will be, see, x square plus y square by x plus y. You are differentiating here with respect to x. X is top, x is down. So, we need to follow it, the quotient rule. What it says once again, differentiation of first by second function is second function square, denominators, second function as it is in numerator, differentiation of first function minus first function as it is into differentiation of second function. Okay. So, this will be now, see, denominator, that is second, differentiation of first by second function square, x plus y as it is second function, differentiation of x square plus y square with respect to x. Here dou by dou x we are partially differentiating with respect to x. So, differentiation x square is 2x minus x square minus y square as it is first function, differentiation x is what? 1. Okay. So, this will be now we get 2x square plus 2xy minus x square minus y square whole divided by x plus y the whole square. So that implies dou z by dou x equals x square 2x square minus x square plus 2xy minus y square. Am I right? 2x square minus x square 2xy minus y square whole divided by x plus y the whole square. That's it. Now, since it is symmetric function, we need not again evaluate for dou z by dou y, because since it is symmetric, we can directly write what dou z by dou y is x changes to y and y to x, vice versa. So, we can write dou z by dou y is equal to x square becomes y square plus 2xy with 2x, it is as it is 2xy minus x square whole divided by x plus y the whole square. Fine. Now, we got both of them. Next is what to prove. Dou z by dou x minus dou z by dou y the whole square is equal to 4 into 1 minus dou z by dou x minus dou z by dou y. So, we will take the LHS first. So, that implies we will write dou z by dou x minus dou z by dou y the whole square equals bracket. See, when I subtract this, LCM is same. So, the LCM will be x plus y the whole square. Okay, am I right? Now, see, dou z by dou x is x square plus 2xy minus y square. Again, see, there is minus here. So, when there is minus sign, always apply a bracket here into dou z by dou y, LCM is same. So, y square plus 2xy minus x square, right? And this whole thing, the whole square. That's it. Now, simplify. So, this becomes now x square plus 2xy, I will open the bracket, minus y square minus 2xy plus x square whole divided by x plus y the whole square, the whole raised to 2. Okay. Now, again this will be again x square plus x square is 2x square, fine, and here 2xy cancels, and minus y square is minus 2y square upon x plus y the whole square, this square. This is again, see, I can take here 2 into x square minus y square, right, 2 into x square minus y square whole divided by x plus y the whole square. That's equal to, see, again let us simplify this properly. You know, x square minus y square is x plus y into x plus y. So, how much possible we to simplify this? So, x square minus y square is x plus y into x plus minus y. So, this will be now bracket 2 into x plus y into x minus y whole divided by x plus y square. So, again here you see x plus y cancels. That means I get the LHS as equal to, so LHS is equal to what? We get dou z by dou x minus dou z by dou y the whole square equals square. 2 square is 4, 4 into x minus y the whole square whole divided by x plus y the whole square. This is what I get in the LHS. I will take this as, say, 1, right? Now we have to prove the RHS. What is RHS? If the RHS, that is, if you prove this equal to same, then we are done. That's the answer, right? So we have RHS is equals 4 into 1 minus dou z by dou x minus dou z by dou y. That will be again 4 into 1 minus, see, what is dou z by dou x we got? It's x square plus 2xy. So, I will put a bracket here, x square plus 2xy minus y square divided by x plus y the whole square minus again a bracket dou z by dou y is y square plus 2xy minus x square whole divided by x plus y the whole square. Fine. So this will be now 4 into. So now the LCM. So what is the LCM here? LCM is x plus y the whole square. This has x plus y the whole square. This also x plus y the whole square doesn't have. So I take the whole LCM as x plus y the whole square. So 1 into x plus y the whole square will be x plus y the whole square. Now I'll open a bracket. So I put a bracket here. So always when there is a minus sign, always put brackets. Otherwise, bracket then open it. Otherwise, you'll end up getting wrong answers. Okay, please keep in mind. Now open a bracket minus x square minus 2xy minus into minus plus y square again minus y square minus 2xy plus x square. Okay. Now if you see here, I will again, okay, see here, x square, y square cancels. So what remains? See, I'll again expand this. So this will be 4 into x plus y the whole square is a plus b the whole square is a square plus b square plus 2ab. So x square plus y square plus 2xy. Again see, minus 2xy will be minus 4xy whole divided by x plus y the whole square. Now again this is 4 into bracket x square. See, 2xy minus 4xy is minus 2xy. So minus 2xy plus y square divided by x plus y the whole square. Now clearly if you see this is a square minus 2ab plus b square is a minus b the whole square, or x square minus 2xy plus y square is x minus y the whole square. So this will be now, that implies we get 4 into 1 minus dou z by dou x minus dou z by dou y equals what? 4 into x minus y the whole square whole divided by x plus y the whole square. Okay, this I take it as, that is RHS number 2. So this is my RHS. So I have my LHS, I have my RHS. See here, both the LHS and RHS are same. Get it? Both. This is LHS, that is dou x by dou x minus dou z by dou y the whole square, also 4 into x minus y the whole square minus plus y the whole square, and also the RHS, which is 4 into 1 minus dou z by dou x minus dou z by dou x, is also 4 into x minus y the whole square upon x plus y the whole square. So both are same. That means we can write, that implies 1 equals 2. Hence it is what? Proved. That's it. This thing is proved. That's the solution, how we do it. I hope you got it clear, right? So that's all in this video. In the next video, we'll move on to composite functions and chain rule, which are again very important for exams. Make sure you practice today's problems, share this video with a friend, like it and subscribe if you find this video helpful. So keep practicing, keep doing the hard work. See you in the next video. Bye.